for coming. This is the third installment, maybe the fourth installment, I think fourth if you count the intro, of modern microservices. Tonight we're going to be talking about continuous integration. And just for everybody out there, this is the Denver Code Club meetup at Kenzan's office off of Wazee and 17th, 18th, somewhere in between those two, next to Union Station. So tonight we're going to be talking about continuous integration, basically building your microservice and all the things you should do, or at least should think about doing, even if you choose not to do them. All right, before I get too far into it, a bunch of stuff about Kenzan. Talked about it the last 3 times, so I'm just going to skip through it. The series so far has talked about, we did an intro, covered everything. We've talked a little bit about platform. We've talked about the application. Now we're talking about continuous integration, working back up the stack. Next time we'll talk about continuous delivery, and then we'll revisit platform and a lot of the low-level infrastructure, because we brought platform in first when it should have been last, because Aspen Mesh came in and did a guest presentation about Istio. So you can go look at that one. So we'll revisit that one later once everything else is built up on top of it. All right, just a quick diagram. Again, coming through the slides of how everything goes together. Platform is your base. It's important. Everything else runs on top of it. I actually probably should flip these two, but You have your application, you write your application of microservices, goes through your continuous integration, which builds your application and tests your application, and then you deliver it onto your platform so it can be exposed to the outside world and people can use it, which is the whole goal of this entire exercise, making a thing that people can use. All right. First of all, what is continuous integration? Before the meeting started, we had a question about continuous integration versus continuous delivery. Those two go hand in hand, and I'll explain why. Continuous integration is the automated building and testing of your applications. It's not actually just on microservices. You do CI/CD on pretty much everything, because you want to build it and you want to test it. The whole goal there is to get feedback to your developers, to let them correct things, let them find problems and correct problems faster. The whole point is to reduce time and drive up quality, or more like drive out lack of quality from your product. It's not a silver bullet though. It's a lot of work. It takes a lot of effort, and everybody has to be bought in on it. They have to want to be better, but if they want to be better, you do continuous integration, put your tests in, build your things, get feedback back, have people basically watch themselves. A lot of this is going to follow the ISO 9000 if you're into like process controls in manufacturing, or lean manufacturing out of the Toyota system. They all follow this plan, do, check, act idea, where you plan to do something, you do that something, you check how you did that something, and then you act to make an improvement, and then you go plan to do that thing again with the improvement and repeat the cycle. This is trying to automate that repeated cycle around building code, building applications. Any questions? If you have any, yell them out. All right. The first thing we need, and this is more of a, so I'm going to start off, I'm going to go through a whole bunch of tools, and the idea here is I'm going through the tools in the order in which they kind of go together. I probably should have put like a slide with steps along the way in here, but there'll be a link at the end that you can go to the GitHub that we're saving all these presentations, so you can pull it up and look at it and see the order. But we'll go through all the tools, and then we'll talk a little bit more about why each tool is where it is and things you should expect out of it. And then I'll have a demo at the end that'll go through just some open source code and use a couple open source tools to show a real simple, obviously simple example pipeline, because I can't pull up the really nice stuff I do for the paid job. All right, the first thing we need is a build service, right? You need the platform that you run everything on. You need the platform that you build all the things with. So there's a whole bunch of these, and it really boils down to your build service is really just a fancy scheduler, usually with slightly different scheduling algorithms. Things like looking for source code, looking for changes in your source code, as opposed to, you know, every night. But a lot of systems, they do nightly, is build it every night. But it's a big scheduler, and it calls a whole bunch of other tools to build your things. We use a lot of Jenkins because it runs on-prem, inside your firewall, inside your office walls. The example I'm going to use is going to use Travis CI. There's Circle CI, GitLab CI. There's a dozen or more of these things. If you're really masochistic, you can just use the good old cron. But I recommend at least one of these first two because I got a lot of experience with them. Travis CI is great for open source. Jenkins is great for if you want to keep the server in-house and you want your firewall arms around it. The second big important thing, and I'm pretty sure I've touched on this one in every one of these presentations so far, and I'm going to touch on it in the rest of them because it is incredibly important, and that's version control, particularly around source. If you don't have this, you might as well just walk away. There's no sense in building a microservice if you don't have version control. You need to version things, you need to be able to improve. The whole point of continuous integration, really it should be continuous improvement by integrating things. But if you don't know where you were, and you don't know where you've come from, and can see the changes, and keep track of the changes you've made, and be able to go look back and see where you've made a mistake and how to fix it, you're not going to be able to improve. So version control is of utmost importance. If you can store your build pipeline configuration in version control, the early, like the 1 point whatever Jenkins, you can't really do that without a bunch of weird plugins. But Jenkins 2 on, you can store a Jenkins file right in with your code. It'll pick it up, and then you have all your configuration in a nice clean version format. And if something goes wrong, you revert back, and it starts working again. Travis CI, there's a file you put in your repository, .travis.yaml, and that's picked up by Travis CI, so that configures how everything works. So all of the big ones, you can put your build pipeline or your build script configuration into your version control. Some examples of this, and if you notice, they're all Git. I've heard good things about Mercurial, but it's still a little old. If you can avoid Subversion, avoid Subversion. But that one's still out in a lot of places, and if you get back to like CVS or RCS, I'm just going to laugh at you. Git is really the front runner here. It's got the most features, and it's the easiest to work with. So GitHub, everybody knows GitHub. GitLab, if you're doing on-prem, GitLab is probably the cheapest, and it's actually really nice, works really well. I use that at the last job. And then a lot of our clients use Bitbucket, the Atlassian suite, with Jira and Confluence and all of those. I'm not a fan of Atlassian stuff, but Bitbucket is actually one of the tools they did pretty well. So all of these, I would say, yeah, go ahead and use them. Again, if you really want to be masochistic, you can go use like the actual Git server and the actual Git web thing and like build your own version of one of these. But especially if you're doing like open source or small projects, just use one of these. Like GitLab, you can install the community edition on your server for free, and you don't get some of the hot rod features, but you can do an on-prem version for free. And it's all the basic features you need, the web interface, committing, branching, pull requests, all that stuff is included. It's like LFS and some of the really weird, really hot rod features that you don't get right off the bat until you throw a few bucks at them. But yeah, all of these are good. All right, now we're actually starting to get inside the pipeline. The first real tool you want to throw at your source code is the linter. The linter does a number of things, and there's going to be a lot of confusion around this. Oh, well, why do you need a syntax checker? Because the compiler will do that. Well, it does validate syntax, but it's a lot faster than actually trying to run the compiler to see if your syntax is bad. But it also does a lot of other things, enforcing coding rules and standards, checking for code smells, unused imports, bad scoping, things like that. And then also check to make sure you've done your inline documentation. We use this a lot here, but at the previous job I used it even more. We had a bunch of embedded firmware they were writing for little devices, right? A thing, I don't see anything around here, but like the little sensor on the door over here, we made those. You gotta put a battery in it, it's gotta run for 7 years without failing, right? This thing helped our code so much. Everybody's like, oh no, it won't do, it won't do. Did this, all of a sudden we had to code so everybody's coding in the same style, and it's finding a bunch of just unused or misassigned or whatever variables. All of a sudden we went through, spent a month doing a bunch of cleanup around the stuff that came back out of the linter. This is an embedded C. Came out of the linter, all of a sudden it compiled faster, it ran better, we were passing, not that we were failing our tests, but we were passing our tests a lot quicker and a lot better. Our battery life went from like 5 years to 7 years. And we're talking like half double A's. So not big batteries. It's not like we jumped from, a coin cell to a car battery. This is jumped from 5 years to 7 years on a battery this big. So linters are actually really good and they run really fast. So you want to do this on every commit. So yeah, in your build pipeline, you commit in, you should have a hook in your build system to build right away. You want to run this every single time and you want to run it first, because this is going to catch most of your problems. Linters are good. The next thing number 2, and you want to run it against every single commit, is some sort of test framework and test runner. You need to pick a test framework and test runner because you're going to use them all over the place, but then what you run on every commit is the unit tests in your test framework and test runner. As I was saying before, right, this is all about, I want to start calling it continuous improvement instead of continuous integration, but that's more of the management process version. Testing is a foundational component. If you don't know where you're going wrong, you can't get better, right? It's all about feedback. So you always want to use a test framework and runner. Number 1, it keeps you sane. It automates things, so you don't have to go manually update all of your scripts to go bring in the next test. It allows you to reuse, and this is a big one, things like mocks, things like fixtures, things like larger test classes and things like that. It lets you reuse all that code, right? It's just like using modules in your application to make your life easier. This is using modules in your test. Use a test framework, just like you would use a web framework. Use a test framework. And then every test runner you should do code analysis or code coverage analysis. Most of these you'll actually use the test runner, which will call the test framework, which will then call your tests, but it'll track what of your code has been covered. Coverage is good. It tells you what you're not testing. Coverage is not a silver bullet. Everybody thinks, oh, I hit 85% coverage, I'm good, walk away, right? Mic drop, see you later, bye. No. I have written tests. I have seen other people write tests that covered all of that code. That code was broken. We covered it. We tested it and covered it. It ran, it showed green on our coverage thing, still didn't do what we wanted it to. It was still broken. So coverage is not the end-all be-all, but coverage helps you show what you haven't tested, and then the more advanced ones will show you how many times you've tested each piece, so it'll help you see where you're over-testing and under-testing and things like that. Good information, not the silver bullet, but you definitely should do it. So just some examples down here. I'm a Python guy, not because I chose Python, but because I've been doing it for 12 or 15 years at this point. So I use PyTest and coverage a lot. PyTest being a framework, or unit test being the other big framework. If you're in a language and you need a unit test framework, chances are there's a unit test framework named unit test. But those are the two I use. There's also like Jasmine and Istanbul are ones more on the browser side, but there's also like Jest we're using in our project right now for our client. We're using Jest for our node code, both server-side API and the JavaScript browser side. So Jest is a good one, and it does both. So, but just go do some research, pick a framework, pick a runner you like, make sure it does coverage, make sure it can be output into some sort of system so you can see the coverage, and you'll be good to go. Most people, continuous integration stops here, but we've got a lot more to go. And for those of you that just joined, pizza and beer in the conference room over there. Yeah, pull up a chair. If you have any questions, just yell them out. All right. This one's probably pretty obvious, right? The builder, compiler, we got to make the things. Continuous integration is all about building things, so we should probably actually build the things. One of the important things that a lot of times we'll miss, especially in the embedded C world that I came from before coming to Kenzan, output useful error messages. If you don't know what that error message means, it's not useful. So pick a builder, pick a build system, pick a whatever, compiler, whatever, that's going to give you some nice, useful error messages. Most of the main ones nowadays, GCC, G++, Clang, Java C, whatever the Object-C Xcode crap is. I'm not an Apple guy. All of those are pretty good about giving you useful error messages, but a lot of times you'll get somebody that wants to use this super hot rod, they built it themselves and it's completely custom and it's the fastest thing since sliced bread, compiler or linker or whatever. Just run. Go find one with useful error messages, because this is how you're going to debug all this stuff when things fall apart. Another thing is, it should be quick. A 30-minute compile is not a good compile. Been there, watch that. There's the XKCD thing where they're riding the chairs around and they yell at the boss, code's compiling, and the boss lets them keep sword fighting. Yeah, you shouldn't have time to do that if your build system is working well. You want it to work quickly, and if it's not working quickly, you need to cut your code up into libraries or modules or whatever your language supports. And that's something a lot of people miss. It's a little bit harder in the embedded C world, but when you're talking microservices, which is what we're talking here, right? This is all running on big servers. This is all running in the cloud. There's more horsepower than you can even imagine throwing at it. So don't nitpick these things. Bust it up to make it readable. Bust it up to make it compile quickly. Because your time, it's got to run quick. Because your time is the most expensive thing you're wasting. If you sit and watch a compile run for 5 minutes, do that. Go fix something in 10 seconds, watch another for 5 more minutes, fix something in 10 seconds, watch it for 5 more minutes. You're going to be spending a lot of time getting coffee, going to the bathroom, reading your email, and not actually doing work. And the worst part about that is it slows your brain down, right? You get distracted, you get distracted, you're doing other things, you lose track of where you are, you get sucked into a meeting, and then you haven't been able to keep up with it and really get that quick feedback. You get distracted and your quality goes down, right? This is all about continuous improvement. It's all about getting better. Distractions make quality go down. We want it to come back quick. And if it's not coming back quick, break it up or get a faster server. All right. So this is all right, so next is the packager. Technically, it can kind of go in with the builder, but I'm putting it in separately because a lot of the stuff that I work on day to day, like Python and JavaScript, you're not really building. You're more like running a bunch of tests and packaging it up into something you can deploy. But I also break it out because this is the thing that you put into your artifact repository. This is the end of your build, right? You can build it all day long. You can compile it, you can link it, you can assemble it, you can do whatever you need to do, but now you got a pile of, .o files or .c files or I don't even remember what Java's extension is that the JVM uses, .class. You have a bunch of files laying around. You got to bring it all into one thing that you can deploy, whether it's a Debian package or an RPM from Red Hat. eggs and wheels for Python. I got a lot of experience with those. Or just like the minified gzipped, you know, whatever dash min dash gzip.js that you give to your web server so they can sling it out faster. This is what you're going to deploy. This is what you need to get to at the end of the day, and this is what you need to bless in your artifact repository so you can say, yes, that's the good one, that's the tested one, that's the one we're going to go deploy. And I have complete confidence that that's going to go out there and only break down 1 out of 10 times. 1 out of 10 is good, 9 out of 10 is bad. All right. So before I jump into this one, the other steps we've gone through so far, right? Linting, unit testing specifically, but your initial test, quick tests, your build and your package, and getting it pushed into some sort of artifact repository, all of that is stuff you want to do on every single commit, right? You want to put it in every time a developer commits on whatever their branch, you want to build their branch, you want to do all these things to get them feedback as fast as possible. If I'm going to go put in, you know, a bad semicolon, or I'm going to go put in something that does something completely sideways, breaks the code, whatever, you want to know as fast as you can, so you want all that to run. Now we're going to start getting into some slower things that you generally want to run on your integration, on your integration branch. So this is going to happen every time that developer on that development branch makes a pull request back into, say, your master branch. We prefer master as our integration. So I'm developing, I get it all good, I do a pull request back to master, then you're going to want to do a lot of these things because this is more in-depth code analysis, it takes a little longer. And again, you want feedback fast, so you don't want them doing 30 minutes of code analysis, 30 minutes of these other things every commit. I want the commit to come back quick. So, integration branch, static analysis. Most of this nowadays is done by the linter, especially on things like Python and JavaScript, because you don't compile them into a binary. But other languages like C# and Java, you do compile into a binary or a just-in-time bytecode or something like that, so there's some level of compiling. You want to check it after the build process so you can check and see if there's any vulnerabilities. And then, actually that's the big thing, is vulnerabilities and bugs. And then you want to report on it, so that way you can see, oh, I did this thing and it all looks good in code, but when I built it, I linked in the wrong library. It's going to find it here, it's not going to find it early on. You know, it's not going to find it before the build. Or there's this new version of SSL, you know, libSSL that has, somebody's found some magical vulnerability because, I mean, it's the vulnerability of the week club, right? Somebody's found, you know, the new Heartbleed or whatever vulnerability. This is what you can use to go check all of your historical binaries and then go fix it. And this is what you're going to use to catch your new code and keep them from having a lot of those vulnerabilities. But it's going to take time because you got to take the binary, you got to process it. You're not running it, you're using it static, but you're going through and doing a bunch of pattern recognition, looking for the mistakes that people know about, looking, you know, kind of like running it all through antivirus before you actually execute it. A lot of that same stuff happens here. So you want to do this on the integration branch. I mentioned the artifact repository before. So I prefer to push to the artifact repository after the security scans, the static analysis. So that way what's in the actual like global artifact repository is your integration steps and then your releases. You can push right after the build if you want, but this is where I like to do is push it into the artifact repository. It's right here. So you need something to store the outputs, the artifacts of your build process, right? Once we're done building and packaging, we have this thing, an artifact. We put it into version control, just like we do source code. A little different, but similar idea. And the biggest thing, the reason why you need this, is it allows you to deploy the same artifact to multiple environments. This is important for everything. This is especially important for microservices. You want to build the thing once, right? We're going to go to release. You take your integration branch, you put your tag on it, you go build it. you go test it, you go test it, and you go test it some more. This is release, you're gonna run the really long test set after the long test set and the quick test set and the unit test and everything else to make sure it's really good. You want it in here so that way you get a hash of it, so you know it's that binary, but you don't want to rebuild it again after deploying to your dev environment. You want to take that same binary you deployed in your dev environment, you want to go put it in prod, because you know that binary is good. You go rebuild it again, you might have a bug pop in, right? Maybe a library updates itself. Maybe your compiler, it had a good day, and the next time you build it, it's going to have since we don't use computers with ECC RAM in them, maybe it's going to have a bit flip in the RAM somewhere, and hey, you got a weird security vulnerability because that one RAM cell was bad that day. There's all kinds of things that can come up, so you want to take that binary with a hash on it so you know it hasn't changed from your dev that's fully tested and put that into prod. So again, you have a reasonable certainty that it's only going to fail 1 out of 10 times, not 9 out of 10 times. So this is really important. A lot of the old systems miss that. Some examples. GitHub releases. You can put it right back in GitHub, right? They get that release thing, you can upload your binary right there, you can call it. Artifactory is one I use on a daily basis. That one's JFrog. It's clumsy, it costs money. I'm not a big fan of it, but it works. Kind of like Bitbucket. It works. S3-like object stores. S3 is a surprisingly good artifact repository because number 1, you can turn on versioning, right? You got to do that. Number 2, they take hashes of everything. It's a big object store, so you put your file up there, make sure you got hashes, make sure you got your versioning turned on, and then you've got all the controls and everything on it, and so you can see old versions, and it's accessible everywhere. Well, almost everywhere. So S3 is a surprisingly good artifact store. And since we're talking microservices and Docker containers and Kubernetes are getting really exciting, Docker Hub, right? It does the same thing. You take your Docker image, it's a stack of those binary overlays, you hash them, you cram them into the Docker Hub, now you can take that one tag and you can go say, hey Kubernetes, deploy that same image. Deploy that same image 10 times, and it's going to be exactly the same every single time. I'm not going to get into some of the stuff you have to do to make this work around like environment variables and passing in config from externals and stuff like that, because I covered some of that in applications, and if there's more questions about it, we can go into it again, do a much more deep dive session on this, but this is a big one. So that was all of the tool sets. Like that was all the big, like you have to have tool sets. There's a whole bunch of little things that'll pop up along the way. Like static analysis for a particular client we're using, they actually have 2 static analysis tools that we have to use per their process. So we don't do that step once, we do it twice. One more of a static analysis, and we're looking for code smells, we're looking for bugs, we're looking for syntax, we're looking for things like that. And the second one is more of the vulnerability scan, the security focus side of things. They have 2 systems that do it. So there'll be a lot of little things like that that'll come up. Sometimes you'll have 2 artifact repositories, right? Any of your Java, Maven, jars, C, whatever will go into something like Artifactory, but then you also have a Docker Hub that you need to deploy to that has different permissions or is in a different location or something like that, so you can deploy elsewhere. So all of these things are just high-level tools. There will be changes. You got to do it unique to your situation. So techniques. Something I mentioned before, and I'll say it again. Make libraries or modules, store them in the artifact repository, use them in your build. It'll make things faster, it'll make things more reliable. So one of the things, basically this is, right? Maven. Everybody hates Java, but this is one thing they got right a long time ago. You build your library jar, you go stick it in an artifact repository. When you go to build your application, you pull 10,000 of those jars out, those libraries, and you put them in your application and use them to build your application. They're all controlled by hashes, they're all controlled by links, they're all in an artifact repository, and you can trace them. You can traceability on them, you can see which one broke. You can lock versions is another big thing about these. When you're building with modules and libraries, lock the version. Actually, say it down here, pin versions. So if you're building with library X for your application. Lock that library X to version, say, 1.0.1 throughout an entire build cycle, and then have a task, after you're done with the release, have a task to come back, update that version, and try running it again and see if it works, and go test it. And then once you update it and you're like, all right, everything's good and working, pin it again. And that way you're not going to run into fun issues like, oh, hey, XYZ company on the other side of the world put this patch in for this library, they updated it, they pushed out a new version, and it broke all your things. Really fun to work on the wrong side of a modem connection. I don't recommend it. But also, on the wrong side of the cloud, you don't want to work on this thing when you've got like this much log window into your cloud system in AWS or whatever. You don't want to be dealing with that. Pin your versions. But use modules, use libraries, so you don't have to rebuild all that code. It makes your life faster. It lets you say, yes, this thing is blessed, it's done, I don't have to worry about it anymore. And I talked a little bit about this throughout the thing. Small, fast builds for developer branches, right? Fast feedback, fast feedback. That's how you get more improvement. That's how you get information back. Build it, get that information back fast. Build it, get that information back fast. Then when you're ready to integrate, go for your big test. Go for, you're not just doing your unit tests and talking to the database now, you're doing your unit test, you're talking to the database, you're talking to those other 5 microservices, and you have, some testers coming in from the other side of the building trying to break the thing for you. So, larger, more coverage, more integration on your big integration builds, small, fast feedback. Your developer builds should be less than 5 minutes. That's the rule. If it takes more than 5 minutes to do your everyday commit builds that the developers do, it's too long, you gotta break it up. Either break up your build into smaller pieces, or break up your tests into different chunks, or you're running too many tests, you gotta test more focused on the piece that you're working on, or your tests just suck. Things like, one of the libraries I was building, we had a microservice that used Redis. It talked to Redis, the database, the caching database. We used it as a persistent database, which is wrong, but worked really well. So we were talking to that, and when we first started doing it, we were testing by talking to a live database. We just stood up a database over there in our test system, and we just flush it, load data, talk to it, flush it, load data, talk to it. Next thing you know, our test set's taken 15, 20 minutes to run for the developer, the every single commit one. So what we ended up doing is we ended up pulling that Redis database back into the actual build container, so now we're not going across the network, we're staying on one machine. Nothing else can use that, there's no contention, there's no network, there's none of that. All of a sudden we're back down under the 5-minute mark, closer to 2 minutes, about a 10 times increase just in network latency. So things to keep in mind. The developer tests should be unit tests, meaning you're testing a unit of whatever, and a lot of times you'll have to talk to some other system, but try and get that other thing you're talking to, get the number of those down as low as possible, and get those things as close to your test as possible to drop latency. So that way you can keep these small, fast developer builds and tests under 5 minutes. That's your rule of thumb. Developer branches, under 5 minutes. On the integration branches, an hour or 2. Your release, before you go out, do full regression, that can take 2 days. I keep moving my arrow all over the place. Alright. Since I've gone through that at blazing fast speed, because nobody asked questions, does anybody have any questions? Or do you want me to fumble around up here and try and show you some code?
I had one quick one. Going back to the tools for CI/CD, I think you mentioned Jenkins and Travis, right, as far as what you've used in the past?
Yep.
I've never used Travis. Is there anything with Travis that sticks out compared to Jenkins?
Can you repeat the question as well?
Okay. For the camera's sake. The question was asked, I've mentioned that I've used Jenkins and Travis as some of the CI/CD tools that I've used. The question was, is there anything about Travis that sticks out? The big one being, it's free for open source projects, which is why I've used it. If you put it on a GitHub repo publicly, I'll show you here in a minute. If you have a public GitHub repo You can go into Travis and you can just turn it on and they'll just run your builds for you. You know, if their system gets overloaded, they'll slow you down a little bit, but they'll run your builds for you for free open source projects. For private repos, you'll have to actually get an account, but that's the biggest thing around the open source community that I think that Travis really has going for them. They're integrated with GitHub, and it's free for public repos. So that's why I've used them. I haven't used Circle CI. I've heard a lot of good things about them. Either they are working and about to, or I think they just did something like that, doing the same thing that Travis is doing to try and boost support. But I started using Travis because it was open, and a friend's like, hey, use this thing for open so you don't have to run your own Jenkins server. Honestly, I spend most of my time in a Jenkins server. Various versions from like 0.94, which is incredibly painful, all the way up through like 2. Whatever, not the latest, but one version back. Because most of our clients use Jenkins servers because they want it running, either they've been running a server since the beginning of time, and Jenkins is just about that old. Have you ever seen one called Hudson? Run. Hudson's the old name. Or they're specifically wanting to keep it on-prem because a lot of their services are on-prem and they're trying to keep it inside the firewall because they're worried about, they're scared of, you know, IP loss. So they have this like neurotic fear. Big companies have this neurotic fear of losing IP, so they try and keep everything inside their border, inside their boundaries, on their internal network, behind their VPN, and so they'll go with Jenkins. Jenkins is the number one. There's some other ones, like the place I used to work, we use the GitLab CI that's built into the GitLab. You have to have the paid version, I think, to turn the CI piece on. But we use that for a lot of the web development stuff at the last place. So we were building our microservices for the big infrastructure I was building there. All of our web testing and all of our front-end testing was done through GitLab CI, and it worked. The only thing there is, because we were running GitLab on-prem, we had to run our runners on-prem, which means we had to run like a 27-inch iMac sitting in the corner that we couldn't find anything else to do, but we needed to test Safari, so they set it up as the CI runner for GitLab CI so we could test Safari browser. Things like that. They were kind of, because it was on-prem. But yeah, I use Travis because it's free for open source projects.
So one question was describing Travis and Jenkins, and you mentioned one reason to use Travis was because if you have open source software, it's free. But would there be a reason to use Travis CI if it wasn't free and if you were paying for it?
All right, so the question was, I've been talking about Jenkins versus Travis and Travis being free for open source. Is there a reason to use it as not free for, say, a commercial project? Yes. It's software as a service. Travis CI is something where you're using somebody else's time on their server. So you don't have to run the infrastructure. You don't have to have the IT guy sitting there babying that server and making sure that server doesn't fall over, because servers are toddlers. You know, they have about the balance of a toddler. You leave them on a shelf too long, they'll fall right off on the floor. But running your server is hard, and if you don't have the team, if you don't have the infrastructure, if you don't have, like especially startups, don't have the crew to run it. So unless you have that guy that's just a systems admin whiz, and he can be, you know, the world's greatest IT guy all in one, you're better off running a software as a service solution for your commercial stuff, unless you have like the big corporate fear of it getting out of your firewall. Right? That's why you run on-prem. Big corporate fear, or you have the guy that can do it because he's done it for the last 30 years of his life. And it's cheaper to be on-prem if you have that guy. But if you're starting up, if you're trying to do a commercial thing, like if it was, you know, me and Russell and Walter, if the three of us just went and started a business, I would not waste any of my time setting up Jenkins. I'd go use Travis, or I'd go use Circle, or I'd go use one of the paid-for SaaS online, just let them deal with it solutions. That's the beauty of SaaS and the beauty of the cloud. Any more questions before I fumble with an
I
example?
also add too, one of the benefits, sorry, just real quick, is if you can use it free for open source, so that's a great way to learn it without spending any money versus like Jenkins where you're gonna spin up the server to learn it. You just do your open source project, learn it, get your .travis file, and then go, all right, I'm ready to spend the money, and just kick your file right down in.
You know what? I'll one up the that you can learn it for free, I'm going to teach it to you right now.
There you go.
All right, so I got 2 links here. The first one is github.com/KenzanLabs/modern microservices. That's where I'm putting, there's some code from the last session. All the presentations from all the sessions are in there in PowerPoint format because we love Microsoft. Same with me, Apple people. We love Microsoft. The second one here is my Kenzan GitHub. So it's github.com/dwilliams-kenzan. And this is an example. So /cicd-example-app. So this is the example I put together this afternoon to show some of these tools off, like Travis, and like I said, I'm a Python guy, so we're going to use PyTest, or we're going to use coverage, and we're going to use Coveralls, which is an open source coverage reporter. It's not quite the code analysis tool, but it lets you report on the unit test, the test framework side of things. So the coverage is the runner, Coveralls is like the reporter thing, so you can see it much more easily. So I'm going to go ahead and pull this up. Let me jump out of here. Oh, it's on the wrong window. All right. So going to the GitHub, we can see here, there is a whole lot of things here, right? I don't think a single one of these files, except for maybe the gitignore that Git gave me, has more than 40 lines in it. So it's not a very big thing. But this is just a real simple application. It's a one-line app. So pull the app up, or a one-file app. So if we pull this up, you can see here it's Python, so just do some imports, grab some environment variables. We're going to talk to Redis because I like Redis. I spent way too many years working with Redis, and it's fast. And then we have our super advanced web server function here. It goes and grabs an image out of Redis, out of a Redis key, and it sticks it in a base64 image tag, and then spits it back to you, so we don't need an actual image server. And then this here is basically turning on logging, setting up a Redis connection, preloading 5 images into Redis, just to make sure we have data, and then the really advanced API.run, turn the server on. All right. So the first thing I would run on this is, in this case, I'm using Flake 8, which is the linter I'm using. So this is just a quick config file, so you can set things in here. All good linters let you exclude things, change your line length. Most of them default to like 79 characters. And as nice as that is to read code on my, VT100 or my Wise30 on my Sun machine that's older than I am, it's not reasonable for screens this big. So I increase the line length, and then I block a couple of things off. Like I like to do 1, 2, or 3 hash marks in my comments to try and organize my code. Linters usually complain about it, so I tell them to shut up about too many hash marks, or like extra blank lines. I don't like wasting space. But I can turn certain rules off. All good linters, you can turn rules off. So, let's see here. Actually, let me pull this up and see if I have my... Okay, scroll up. All right, here we go. This is good. So this is when I started actually using the linter against that little chunk of code you saw, 40 lines or so. So I ran just Flake 8 and then my file, or you can do it on a module, you can do it on a folder that'll do everything inside of it. And you can see here it just puts out a bunch of errors, and then what the Windows command line doesn't show you is the return code. If you get any errors whatsoever, it'll give you a non-zero return code, which will tell your build system, something's wrong, break, fail the build. So you can see I'm failing a lot of builds here. But things like, hey, look, 142,000 character line is a little bit wider than my 79 limit. So I hard turn those off. That's the pictures. I turn those off for those 5 lines. But you can see too many lines, too long a lines, things like that, that the linter will show up. And this will do a lot of things. Yeah, just to test it. So this is one that I was making sure that it was doing everything I thought it was. So like in Python, if you have an import, but you don't use it, a lot of people stack like 50 imports at the top of a file and use 3. It's a waste of space, it's a waste of memory, and both while the program's running and in your code base, and it just confuses people and stuff like that. Clean them up, right? It's a big ugly code smell. So it'll actually give you a nice error there saying, hey, you've got unused imports, go clean those up. So, and that again, that'll fail the build. So that's the linter, that's number 1. The next thing I ran is, I'm actually going to pull it up over here so you can see the command. So this is the Travis file. You can see, super complicated, right? This is the build pipeline. This is all of it. Yeah, there's don't notify me falls off the bottom. But the thing I want to point out first is Flake 8 and then coverage run the application with a PyTest framework. So what that's going to do is it's going to take the PyTest test framework, it's going to run the test that I wrote against my application, and then coverage is that test runner. It's going to track the coverage to see what of my code was covered. The output of that, if you were to pull it up and look at it, it's a big ugly, usually XML file. But we can go over to a tool like this. This is called Coveralls. It works fantastically with Travis CI. There's just a line later on, but I use it with Python, and you can run Coveralls anywhere, and as long as you have your API key, it'll go. But it'll pull up. So if I go here, see I've got build number 10, came from Travis CI, 58%, good score. So good they made it red. It'll also show up or down coverage here. So right now this is flat, it stayed the same, but it'll do a little up arrow, a little down arrow, depending on if coverage went up or down. A lot of these you can set special rules in the coverage system to say if your coverage goes down or if your coverage is below a threshold, fail the build. So if we go here, it's showing my file, and you can see, it's hard to see on this TV. These are all highlighted green, really, really light green. One of those down here. Here we go. See how these ones are pink? That didn't run when I ran my test because I imported this piece up here, the actual function, because this file's not written well. I imported this and I ran this. I imported that, tested this, but because I didn't run it as a regular program, my main function didn't run, so there's no coverage here. So then the coverage tool shows me, hey, nothing's covered. This is a reporter piece. This is not required, it's a nice to have, but your coverage is what actually goes and figures all this out. Then you can put it into coveralls, or there's like half a dozen different reporter formatter things. But this is that coverage thing showing you what you haven't even tested yet. So this is saved my bacon a few times. Only a few, but a few times. Unit test, small scale integration test a lot more. All right. So the third step here in the script is the build. So we did the linter, which is Flake 8 in this case. We did the unit tests, test framework run. We did the actual Python you don't build. So Docker technically in this case falls under that like build/package step, depending on who you talk to. So I do that, and because I'm not actually going to deploy this somewhere, I'm going to not do the push to Artifactory, or any artifact repository. In this case, I'd probably go to Docker Hub. And then because it's an example, and I didn't want to go try and fire up some of the big static code analysis things, I didn't do the code analysis step. That would have come after the Docker. But then, yeah, here's that coveralls command that pushes the results. So, oh yeah, and like, set my Python version to 3.6, build on master. I need Docker and Redis. as my available services. So this is 28 lines is an entire build pipeline in Travis. You update this file, Travis picks it up. So Travis, it looks like this. Well, that's the output. So Travis looks like this. And it'll go through, it'll run, it'll give you green, it'll give you red, things like that. And then it'll come down here, and this is one of the nice things about it, is it goes through and it shows you everything that happened. So this is all collapsed because it's all boilerplate, but you can come down here, hey, I installed a bunch of pip things, I ran flake 8. Flake 8 exit with code 0, and it's green. Hey, look, my linter's successful. I have pretty code, as opposed to smelly code. Come down here, ran my coverage. The command coverage ran, exit was 0. In fact, one of the things I had to figure out here is I had my coverage command wrong. I had -- source instead of -- include. And so it was coming out and it was succeeding, but it was saying no coverage was reported. Because I could see it here in the build tool, I can figure it out, go look it up. If you're doing a single file, you gotta do include in the coverage tool. But yeah, so it showed up, it's green, everything's good. Then I do my Docker build. It spits out all the lovely stuff from Docker. And then eventually at the bottom, we get to everything's good. So we get a green build. I think the grand total this one ran in, because the open source takes a little time to fire up, 2 minutes and 3 seconds, including a Docker build. Granted, it was one unit test that ran in 3/4 of a second. Most of the time was spent in spinning up. Most of that 2 minutes was spent in spinning all this stuff up. But they even give you seconds of different steps all the way down the side. So that's how you run Travis. That's how you do CI on an open source project. There's 100 different tools. I just happen to know how to use Travis, so I used it. So now I can go tweak things. I can go add tests. I can go do all that. I commit, Travis rebuilds. I commit, Travis rebuilds. I'm going to see in 2.5, 3 minutes if I did something wrong. So, any other questions? All right. I think that's everything.
I do have a question if that's everything.
Sure.
With Docker containers, how does that benefit your CI/CD pipeline?
It benefits CD far more than it benefits CI. Truth be told, it's actually a bit of a burden on CI, because usually you have to have a second artifact repository unless you have something bigger. Like Artifactory by JFrog does Docker and Maven artifact repositories in the same thing, so it's not really much more. But you also have a lot more time that you have to put into that, usually build and then Dockerize or package into Docker. So usually it adds time, which is why you generally do like a Docker build before you're actually gonna go push it out to your dev environment on your integration builds. So really, CI-wise, it doesn't add a whole lot. The bigger change on what Docker does compared to, like, say, running a Tomcat with a jar or something like that, is it makes your CD, it makes your continuous delivery more atomic, right? You're not running that same Tomcat server and trying to slide a new jar in and hope it loads it right, especially if you got a cluster running Adobe Lifecycle, man, run from that. Spent way too many years in the data center at 3 a.m. doing that. So instead, with Docker, you would have that whole Tomcat server with those jars preloaded and pre-tested, so when you push it out to production, it's going to work. Either it works or it doesn't. And if it doesn't, it jumps back to the old version that you know works, and you're good to go. It makes it more atomic because you're quite literally packaging the user land of your operating system in with your program.
If I hear that correctly, you're saying that if it works in my test environment or in my build in my CI/CD pipeline, it should work in all the other environments.
Docker images, yes. The only time a Docker image wouldn't is if you either have an architecture change on your hardware, which chances are you don't, because everybody and their dog runs x86 64 now, AMD 64. The other thing that would be is if you had basically the configuration that your production environment passed into your container, database connection, passwords, things like that, if those are passed in wrong, yeah, that Docker container is going to fail. But it's not because the container is doing anything wrong, it's because you have bad configuration. But if it works with good configuration in your dev environment, and you pass the exact same image out, it'll work with good configuration in your production environment.
So I also hear that if the dev environment's right, runs right on dev, QA is doing stuff, doing the automated testing and all that, that runs right.
Yep.
Then if it went to, then if all that does good, you put in UAT, made some smoke testing and production, it should be, other than configuration, which sounds like the variable out there, it should run.
Right.
The environment itself, and what I see is a lot of the whole environment's messed up between QA and UAT and prod.
Right, like the biggest one I've actually been dealing with recently. So I'm deploying a pipeline tool called Spring Cloud Data Flow. Right, it lets you go deploy data streams into this fancy Java Spring-based environment. Pretty slick tool, but I deployed that containerized into a cluster, and in this cluster it worked. In this cluster it burnt down. Come to find out, what it was is the second cluster did not allow internet access to go download jars from the Maven repository.
I just ran into that as well, yeah.
So that's the kind of issues, if you're using something like Docker, that's the kind of issues you're going to run into in your production environment. It's not going to be your build is wrong because you've proven your build is right. It's going to be all the other stuff.
Insulates you from some of the environmental issues because again, you know, the OS up, you
Right.
contain that within the container. Right?
You have
so it's all coming along with it.
Right, with Docker, you have the kernel that stays with the machine, but then you build your application and the user land around it. So all like the shell and all that kind of stuff is packaged up with your application. And all the Linux kernels since like 2.0 have had basically the same interface. They added some features here and there, but for the most part have had the same interface. So that way, as long as you're on a kernel that's new enough to run the Docker server program to actually load the images up, you're going to be on a kernel new enough to run your Docker container, and all your user land, all the stuff that's going to bite you, all your libraries, all of that kind of stuff is in that Docker container with you. So yeah, you know what this is, and you have a hash on it, you have a checksum, you have it blessed, you know that's going to work. If you have a problem, unless it's some crazy freak of nature thing like flipping bits in the RAM by gamma rays from outer space or something, you know that it's not going to be what's in the Docker container that's causing the problem because you've tested it in dev, you've tested it in QA, you've run your smoke test against it, and that's why you pass artifacts. That's why the artifact repository is so important. You build your artifact and you test it, and you pass it to the next environment, you test it, and you pass it to the next environment, and you test it, and you pass it to the next environment, and you deploy it, and it's in production. And it's been the same exact binary the whole way, so every single one of those tests gives you more assurance that that container or that binary, no matter what binary it is good. That's why you pass artifacts.
Right, makes sense.
Alright, so just for grins, I went ahead and fired up the server so you can see what it does. It does this. Right, it's going to break on me. Oh no, there it goes. Incredibly important application, right? That's what my 40 lines of Python does. I think the hardest part might have been figuring out how to get Redis to run on Windows. So, alright, any more questions? Thank you all for coming. Thank you for coming. Come again soon. I don't know off the top of my head what February's meetup is going to be, but I think the continuous delivery piece, the CD piece, the second part of CI/CD, I believe that one's going to be in March, but just keep an eye on the meetup page for it, and we'll let everybody know and all that kind of stuff. So I'll be doing that again, like I was talking about at the beginning, or actually before the stream started. We'll talk about some Capstan, which is a project, one of our projects, a Kenzan project. It's open source, you can go look it up. That's basically a rapid deployment of the Spinnaker continuous delivery platform onto GCP, Google's cloud platform, with firing up Kubernetes, firing up Spinnaker, loading on Kubernetes, and then deploying a test program. So That's a lot of what we'll be talking about to illustrate the whole continuous delivery thing, and then we'll talk about some of the places where people, run aground, the ship runs aground, since we like, Spinnaker likes nautical metaphors. So. Oh no, really, like go dig through all their microservices. Every single one is a different nautical metaphor. It's actually pretty hilarious.
Orca's my favorite.
Orca?
And I won't spoil it, go look at the repo.
Yeah. Orca's a good one. Alright, if there's no more questions, thank you all. Russell.
Hiring and giving away swag, I was told that.
Alright. So we're always hiring. If you have any interest in working for Kenzan and all the things we work on, video streaming platforms, Spinnaker, CI/CD, microservices, we're getting into the telco space, at least on the engineering side. Not like phone systems, but like software build system, engineering process, that kind of side. If you want to work here, go to our website. Again, like the slide I passed over at the very beginning. You can go look at that. Go to our website, kenzan.com, and I think there's a careers page or something like that that you can go look and see what job offers we have open. And then the other thing being swag, it's the sticker table, right?
Mm-hmm. Yeah.
So there's a few t-shirts, and there's a bunch of stickers over there on the table by that whiteboard. Please don't take the microphone stand. I really don't care about the little computer stand there. We've got 100 of those. But the stickers and the t-shirts, those are fair game. So please go take t-shirts, go take stickers, take more pizza, and grab another beer if you want.
I was sorry, I was kind of late today.
Sure.
I didn't realize traffic was bad.